Internet, hello, once again. Let's skip the long introduction, jump right to what we are going to do today. So last week I showed you how to install a dual extruder, but that required you to remove the fan that runs off the printer. So now I'm going to show you how to keep both extruders and a heated bed and a fan. So I'm going to rewire a transistor into one of the available pins and then make that run the fan output. So first things first, let's make the circuit. Alright, so to test this circuit, I'm going to be using a regular Arduino Uno for this. I currently have a code on the Arduino that tells pin 13, which has an LED on it, to turn on for 5 seconds and turn off for 5 seconds. So I'll show you what that looks like right now. So what I'm doing right now is hooking up ground and 12 volts. Yellow is going to be 12 volts for my bench power supply, and ground is going to be this black cable over here. Once the Arduino initializes, this light turns on for 5 seconds, and then it turns off for 5 seconds. And so this means that the logic is being output through pin 13, and that's where I'm going to set the fan up. Now this is a 12 volt DC fan. I can hook it up to pin 13 and then put the negative terminal on ground, and it will spin every single time the Arduino tells pin 13 to go high. But it's not going to spin very fast. It's going to be a little bit hard to demonstrate this, but this is a dryer sheet in front of the fan, and the fan is on, but it's not moving the dryer sheet at all because there's not enough power being pushed through the fan. This is a 12 volt DC fan only getting 5 volts electricity. So we need to get 12 volts of electricity through this fan with a 5 volt signal coming from the Arduino. And this is where our friend the transistor comes into place. This is a TIP31C type transistor. I have a lot of these laying around because this was part of my first circuit project back when I was in high school. I'll throw up a schematic so you can see what this looks like up close. And I'm going to be using this to power the fan with 12 volts of electricity. The first thing you want to do is identify which pin is what. This is the base, the collector, and the emitter. So the collector is going to actually hook up to the negative terminal of your fans. Left side, your base, that's going to be the signal coming off of the Arduino. So that's going to be pin 13. We want to apply 12 volts of electricity to the fan directly from the power supply, and then the emitter on the transistor gets grounded to the power supply. And so now the fan is running at a full 12 volts electricity instead. So if I put the dryer sheet back in front of it, you can see it's actually moving around this time because it's not using 5 volts electricity, it's using the full 12 volts. So now that the fan is running at full capacity, this isn't going to be the fan that I put on the printer itself, but I will be putting this circuit on this PCB. So let me just use my soldering iron and put this circuit on this little thing now. So this is the exact same circuit I had before, except I'm using the bench power supply to only supply power to the Arduino and the input for the fans, and I've moved the entire circuit to this small little printed circuit board. So now I'm going to cut the circuit out of the board, and then I'm going to put that on the printer. So this is what my transistor board ended up looking like. I have the transistor here, I have the input for my 12 volts here as a female pin. I have that exact output ran in parallel for the fans that I'm siphoning power from. This is the output to the fans on the actual board that passed through the transistor, and then this is the signal pin that comes from the Arduino. So, like I mentioned in the previous video, in order for you to have dual extruders, you need to remove your fans from D9. But we still want the fans to work, so we're going to have to rewire them into the system. And that's why I made the transistor board circuit. So the output to the transistor circuit is here, and that is the output of the transistor going to the fan. So this goes to my fan over here. So this is the signal pin that goes into the transistor board, and this goes into auxiliary 2 for ground and digital 63 right there. So the only thing that's left to do is power this circuit, and that uses this connector on the female head in there, and then the end of this goes to the 12 volt auxiliary right above your X driver. So this output goes to the lighting array on the 3D printer that is aftermarket on my printer, and then this output goes to the fan that cools the ramps board. So I'm siphoning parallel electricity from the circuit that runs the fan underneath the board for a logical fan that runs for the extruder, so I can keep my dual extruder but have a logical fan system that I can use with pulse width modulation. And because the entire back of this is exposed electronics, I'm going to be using electrical tape to insulate the entire portion here. This cable right here is the 12-volt auxiliary cable, and that powers this supply. This is run in parallel with this wire, which is the fan that runs underneath the ramps board. The signal wire from auxiliary 2 goes into the top of the transistor board, and then the wire for the fans goes on the bottom. Of course, now that you have everything wired up and ready to go, if you go to control, temperature, and fan speed, the fans won't come on because the firmware doesn't know that the fans are now on a different pin than what they were originally set at. So we have to go in the firmware and change that now. Alright, so now we have to go change the pins in the firmware. So if you go to your firmware, I'm using the Robo 3D R1 Plus firmware. And if you go to the right and head over to pins.h, you'll see the fan pins defined when there's fans in the code, but now that you're using motherboard 34, that means you now need to find a different place to put your code. So what I've done is I just interjected a small version of code that says if motherboard is 34, then define the fan pin as 63. Now digital pin 63 on the ramps board is here. So on the screen I have the 2 pins that I am using for ground and 63 for digital. Now because it's an analog input as well, it can do pulse width modulation, which gives you the variances in fan speeds. It also isn't assigned to anything else for the printer, so we can use that to run the fans instead. So after you put this small little part into your code, you should be able to upload that to the printer, and then so this time when we go to control, temperature, fan speed, and we increase the fan speed, the fans actually spin up now. So I kept control of both extruders, the bed, and I added the fan to digital pin 63. Once you've verified everything is working properly, you can begin to put the carriage back together, and then you also want to make sure that the fans are still working as well. So run those every now and then to make sure that you still have logic from your LCD controller or your computer to your new fans while the dual extruder is still active. So I hope this video helps you install your filament cooling fan post dual extruder upgrade. If you have any questions about this video or suggestions for future videos, make sure you leave your comments down below. If you like this video and want to see more like it, make sure you click that subscribe button. So in the next few videos, I'm going to cut back on doing some modifications and instead show you what the 3D printer's been making and what I've been doing around the house. So until then, thanks for watching.